Welcome everybody. Welcome to a new video. Happy to have you here. My name is Hendrik and today we are starting a new series. And I call the series SAP EWM Meets Automation. And this is about discovering the MFS component of EWM in cooperation with the SAP EWM team at Swisslog. The idea of this series is to explore some of the MFS features in EWM which are needed to run warehouses which are using automation. This is something which is not that common in terms of available documentation, but this is something which becomes more and more relevant in the future where we are automating processes in our warehouses. Today, the first one is about the Putaway strategy, which is something you need in every warehouse. So for today, you just imagine we are working in an environment where we have an automated high bay warehouse where we are storing pallets. So how do we do the Putaway in such a warehouse? You usually drop a pallet on an infeed, something like this. Then the pallet travels via any eye point, and somehow the system finds a bin in one of the aisles, which are operated by cranes, which are picking up the pallets at so-called pickup positions, something like this here, move it to the final bin, and then execute the Putaway. So this video will be all about the coding, the logic, the strategy, which is available in EWM standard, which helps you to find bin in such an environment, which is significantly different from manually operated warehouses. We have some constraints and some requirements which we do not have in a warehouse where the Putaway of such pallets here happens manually by, for example, by a forklift or hand trolley. So as a rough agenda, we will start with the spot where we find the standard strategy. I will show you how this is included in the standard coding. Then we will look at the content, the logic of the strategy, what's actually happening there, what is implemented by SAP. And to close this video, I will give you a quick insight about how to enhance here in a clean and accurate way. So where do we find the standard strategy? It's pretty simple. There are a couple of different bodies. For example, the one which you see on the screenshot here, core PTS empty bin, there is another body. I listed it down here, MFS act case _RBD. In both cases, we have a standard fallback class. And this standard fallback class is making use of class SEWM CL_core_putstra. So this is the most important class in the context of standard EWM MFS Putaway strategy. And as I said, one example where this is being called is the body for empty bin determination, and it's called via the fallback class, which you find here if you check, for example, via SE18. So what is the content of this class? What is the content of the standard strategy? And in the next around 10 minutes, we will look at the details of the fallback class that I just mentioned. That on a high level, that's just a storage type check. So is the storage type actually relevant for the strategy? Then we have AL validation. We have different strategy variants. And then at the very end, we have some MFS specific checks, which are executed as part of the standard coding, which are not needed for non-MFS storage type, for instance. First step, as I said, is the preparation. So we check, is the storage type actually relevant for the MFS strategy? And the precondition is kind of obvious here in the storage type customizing. We need to have role J, which is used for automated warehouses. And you see here, this is the interface method, the one which is called by the coding which is calling the body that I just showed you. That's always the case. At first, we call the interface method at the beginning. In the interface method, we check at first, is the storage type actually relevant for MFS strategy? So even if you are doing the put away for non-MFS storage type, we will run through this check, but then you decide, okay, it's not an MFS storage type, so return from there. Let's assume we've passed the check. So the next step is method that empty bin at WT create. And the first thing that we will do is to determine possible destination ALs. So in my picture here, you see, I think 1, 2, 3, 4, 5, 6 different ALs. And the question is, which of these ALs can I reach for the HU that I want to put away right now? So the task that I want to create right now, which are the possible ALs that I can reach? So if you look at this sample picture here, if I am at this identification point here, potentially I could reach all of the ALs. But if I am, for instance, already here at the infeed for this AL, and I do a redetermination of the destination bin, then the reachable ALs from my communication point is only that one. Communication point in terms of a spot on the conveyor which communicates with EWM. EWM perspective, it's a bin, and the subsystem, the PLC, talks to EWM at communication points. And here, in my example that I just mentioned, we talk to EWM here at the beginning of the AL, or here at the I point. And the reachable ALs are different when you compare those two communication points. Another option, if the pellet or the HU is not sitting on such a communication point, is that the HU is sitting on a resource or on a bin. And if it's sitting on a resource and on a bin, again, the possible destination ALs may be different. So assume the pellet is already sitting on the crane. So it's sitting on a resource from EWM perspective. And if I'm sitting on a crane in a specific AL, perhaps in the context of rearrangement or in a context where the crane wanted to do put away, but the initial destination bin is blocked and I need to search a new destination bin. In this context, there is also no other reachable destination AL other than the one where I'm just operating in. So I need to find a bin in this AL. If I can't find a bin here, I need to move the pellet out of the AL and then determine a new bin from another communication point onwards. And last option is that the HU is on the bin, actually. So that could be a scenario where I need to do rearrangement of a multi-depth bin. So the pellet on position on the back position should be removed from stock. So and I need to rearrange the pellet from the front position, and then just need to create a task for this pellet. And I also have only the current AL as a possible destination. ALs which are reachable for resources can be maintained here in easy access. It's MFS master data. And on the previous screenshot, you saw, on the previous slide, you saw the ALs which are accessible by communication point. That's in the MFS customizing. So we have determined the possible destination ALs, and the next main step in the main method here is to filter the possible destination ALs. And here we call the method filter ALs from the method we were just in. And beginning of the method filter ALs, SAP put a pretty nice summary of the steps which are executed here. So here you see the program logic, and it starts with evaluating the status of the resources. Then we look at the communication points which are assigned to the resources. So again, remember, we are in an environment where we do the put away with cranes. which are our resources. And each crane has here a pickup point, which is essential for executing the put-away, because if I can't pick up the HU, I cannot put away the HU. For this purpose, we read the status of the resources, then the status of the communication points, which are required to do the put-away. And at the end, we will also calculate the capacity and the number of HUs which are actually traveling towards those communication points and ALs, and take this into the consideration for the decision. But we will look into detail here also during the next minutes. So step 1 and 2, here's a screenshot of the program logic that I showed you before. First thing, as I said, we read the resource and we evaluate whether the communication channel is running. So this is a technical connection between EWM and the PLC, where the TCP/IP communication is happening. So communication channel needs to be up and running, obviously, and the resource needs to be available. It could be that the crane is in a failure status because some construction is going on. It broke down for any reason, and obviously if the crane for a specific AL is not available and it's not working, then we cannot do the put away in this AL. So we filter the AL and remove it from our list. Next 2 steps here is the status of the communication point. So we check whether it has exception code. So it is possible to put an exception code on the communication point here. And for example, if the AL is currently set up to only do stock removals, then I set an exception code on the pickup bin so that no put away is possible anymore for the given AL. So that could be the case. If this is true, I remove the AL from the list. Another thing which is checked here is the total capacity. So the allowed number of HUs moving towards the AL. Yeah, we will look at this later again, but the capacity is important to understand how many HUs I can send towards the given AL without causing a jam or traffic or deadlock. Just as an example, an infeed of a high bay might be able to buffer around like 3 or 4 pallets, but then it's full. If the crane is not operating for some minutes, then there will be a traffic jam. Or if I just send too many pallets at the same time towards the same AL, there would also be like a traffic or deadlock. So there's like a capacity of 4, 5, 3 pallets, whatever, and that needs to be considered here. Last step here is that ALs which do not have a resource at all are also removed from the list, obviously. Again, just checking the data that we collected before. And at the very end, this is this step here. We are still in the filter AL method. We set in our internal table, internal structure here, the AL level structure, which is appended to the internal AL level table later. We are having a flag like exclude for determination here. So based on the checks that we did before that I explained in the previous slides, we set this exclusion flag in case we don't want to use this AL for put away. Last step, we are still in the filter AL method, is not about excluding something or some ALs. Kind of, yeah. I mentioned the capacity calculation before, and here we are again coming back to the capacity calculation at the very end. So we collected the data up front, and now here we at first determine the number of HUs moving towards the AL. There is this HU move table where the MFS component tracks the HUs which are moving towards the AL. And we also consider the HUs which are already sitting on the pickup points. And then based on the max capacity that we determined before, we calculate here like the max capacity minus the number of HUs moving plus the number of HUs which are already there. And this is the free capacity here. And then at the end, we flag the AL for exclusion in case the free capacity is less or equal than 0. So that's another reason why AL could be flagged for exclusion in the strategy here in the filter AL method. At the end, we have the result. I mentioned already the structure and the A level structure. So here, as a result of the filter AL method, we get an internal table with all the ALs that we have and with all the data that we collected in the methods before, like the exception codes of the resources, the communication points, number of HUs like moving, number of HUs already there, capacity, etc. And also the exclusion flag that we set or did not set for the ALs before. So we are back in main method that empty bin at WT creation. So that's the method that called the filter AL method before, and this method is calling now the that putstra variant method, and here we determine a putaway strategy variant. I don't want to go into detail here. The main idea that EWM gives us here is to define different variants based on the content of the HU that we want to put away. And SAP is differentiating between pre-picked HUs, so HUs with a reference to ODO, for instance. So that may be a scenario where you are doing picking in a manual area, like partial picking, for instance, and you want to buffer the pick HU or ship HU before you send it out. So you take a pick HU and move it back into the high bay and buffer it there up until the final shipment. And there should be a specific strategy for those kind of pre-picked HUs. And the second variant that we have is a single product HU. So HUs only having a single combination of material and batch. And then the third option in the standard implementation here is like undefined, which means like neither one nor two. Good, and the next step is then the determination of the empty bin finally. And here we have a case statement with a put away strategy variant. So the three different variants that I mentioned before. In your own implementation, you can, of course, create your own variant. But we will look at the single product variant now, which does not differ much from the other variants. I think SAP just wanted to show you here how we can implement different strategies, but did not really differentiate the ones that SAP implemented by themselves. So important input for the determine empty bin method here is the A level table that I mentioned before, and the penalty structure. So the penalty table. You need to understand here that we are in the context of standard put-away customizing. So we are looping above the storage type search sequence here. We are looping above the sections and the bin types. There's a standard strategy where you prefer specific storage types, sections, and bin types. And this is also being handed over to the determine empty bin strategy here. So although we have a separate strategy for the MFS put-away storage types, we still consider the sorting by the section and the bin type that you can maintain in standard customizing. And this is also being handed over here as an important import. So in the determine empty bin method, first thing that we are doing is to delete from the A level table the ALs which have the exclude for determination flag active. So for example, as I explained before, if the resource has an exception or the capacity of the pickup point is reached, we set this flag. And in this method here, we then ignore all the ALs having this flag. Easy logic. And then we start the loop over the remaining ALs. And within this loop, there is, again, another method called select empty bins. And this is being called after we've checked the storage type customizing and enriched the penalty table a bit. I skipped this part of the coding, which is not too important here. But this happens before, and then we call the select empty bin method. And what's happening here? Empty bin method some MFS specific checks are implemented. I mentioned this at the very beginning of the video. And one of these very specific checks is the consideration of the required bin depth of the HU type. So in the context of a multi-depth storage, this might be relevant. So this is here. This method is getting the required bin depth. And another check which is happening here, which I want to just mention without going into detail, is the consideration of the rough bin determination. So maybe there is another bin, another HU traveling somewhere out of the high bay, which picked specific bin in the context of a rough bin determination. So rough bin determination means I take a bin, reserve it for me at some communication point somewhere out of the high bay, and then redetermine later whether I really want to take this bin or not. But still, this bin is kind of reserved, in a soft reserved, and we want to ignore this and don't take it for the HU which we are trying to put away right now here. This is happening here. And we remove it from the list of possible destination bins. So finally, the select empty bins method, after having executed the checks that I just mentioned, it hands over a table of possible empty destination bins, which are in ALs that we did not exclude from the selection based on the logic and checks that we executed before and that we looked at within the last 10 minutes. So this is handed over to the caller, which is the det empty bin method here. And then the final step is the sorting, the application of the sort sequence for cross-line stock putaway to the bins in this table. And this way, it's possible for you to achieve an equal utilization of multiple ALs. If you remember the picture we looked at the very beginning with the 6 ALs, and a common strategy is to have an equal distribution of HUs across the ALs. So you don't want to have like AL number 1 and 2 fully occupied and the other 4 ALs running empty. That will decrease the performance of the overall system, because the 2 cranes of the first 2 ALs would have to do all the work, while the other 4 cranes would be sitting idle. That's not something that you want to achieve. So with this cross-line stock putaway, the sorting which is applied to the database table for the bin sorting, based on the activity, will make sure that the bins at the front of all the ALs have a similar sorting number, and the ones at the back of the ALs also have a similar one. So if we just sort by this number, we will achieve an equal distribution of pellets across the ALs indirectly. So final step already. Now almost done. And the final step is kind of funny here. We are still in the method that empty bin, and here this step 6 is about the decision whether the empty bin search should run or not. And this is basically saying here, if we found a bin, so if our table is not initial, we found a bin, we do not want to run the non-MFS putaway strategy here, which makes sense because we found a bin. Why would we want to run the non-MFS strategy? But the else part is also fun. Yeah, if we did not find a bin, if the LT, LA, GPL here is initial, then we also do not want to run the non-MFS strategy because we are in an MFS storage type. So no matter whether we found a bin or not, we will not run the non-MFS put-away strategy. And as I promised in the introduction, I will give a quick outlook about how to enhance here, which is pretty obvious. If you want to create your own implementation of MFS put-away strategy, you might want to take the standard fallback class and copy the fallback class, create a subclass, whatever, but don't start from scratch. Make use of what the standard has in the standard fallback class. And you also want to copy the putstra class, which I mentioned at one of the first slides. This is a standard class which is carrying all the coding that I showed in this video, and you might want to copy and inherit from this class and then implement and add your own coding. And how you do that? In detail, you can derive from node 2070351, which has two other examples for adjustments of the MFS Putaway strategy. Some example scenarios here. The one is about multi-depth storage, and the other one, I think it's also about multi-depth. I don't remember in detail, but at the end, SAP also recommends here to create subclasses of this core putstra class, and then create new body implementations and call your create a new implementing class, and then call your implementation instead of the standard fallback class. So you have a clean approach for standard enhancement here, and as I said, that should also be the summary here. There is already a lot of logic available in standard. I'm 100% sure that there is no automated warehouse out there which is running purely on this standard strategy. There will always be some specifics based on the hardware, based on the subsystem vendor, and so on. But there is a good base. It's kind of hidden. You know now where it is, and you have a good basic understanding now. Having said that, I want to close this video. I want to say thank you to the Swisslog team, which helped to create this video, which provided some of the input, and the team is happy about getting in touch with you in case you have projects where you need to include automation equipment. If you need help integrating SAP EWM with automation hardware, feel free to reach out. Put some links, some context in the video description, so you will find everything that you need in order to get more information of Swisslog and EWM integration and with Swisslog. Apart from this, I hope that I see you again in the next video. If you don't want to miss it, subscribe to the channel. And if you want to get the full script of this video, feel free to visit WMexperts.online, where everything is available as a blog post as usual. Thank you for now, and goodbye.